This is the first of 3 videos that I'll be making that covers how to solve rational equations. In this video, I'm going to go through all of the basics of the process of solving. The second video is mostly just going to cover some slightly more difficult examples, and then the third video is going to go over some particular kinds of word problems that can be pretty challenging for people. So this is the best place to start, where you're going to learn all of the essentials of how to actually solve rational equations. So, what is a rational equation? We've seen similar things throughout this course. It's a pretty straightforward definition. It's just an equation that has at least one rational expression. And so here's the thing. Technically, pretty much every equation that you've solved, not including the radical equations from chapter 5, is a rational equation. They're just generally rational equations where the denominators are 1, which is pretty boring. So usually when we're talking about rational equations, what we really mean is we have variables in denominators. That's where it's actually useful to think of them that way. So for example, something like 2 over x plus 4 minus x over x plus 7 equals 4. Right? This is a rational equation. We're not going to get to this one just yet because it's a little bit too complicated, but we'll see ones like this a little bit later on. So, let's start with something more in line with what you might have seen in grade 9 or grade 10. Solving x over 2 plus 3 over 4 equals 2 over 3. So you'll notice there's no variables in the denominator here. This is a pretty basic example where we just have fractions. And you would have seen this probably in grade 9, maybe even grade 8. It is something that we know how to handle. So in general, though, this will give us a good intro. When solving rational equations, we actually don't want to have denominators. We don't want to have fractions. Fractions are annoying, especially when it comes to solving. So our first goal when solving any rational equation is almost always going to be to get rid of the denominators. The question is going to be, how do we do that? Depending on the equation, it might be easier or harder, but you already should have pretty much all of the skills you need to get there. If you haven't watched the adding and subtracting videos, especially the 6.3.2 video, I would definitely make sure that you have a pretty good handle on what was in that before you come to this, because we're going to be using a lot of similar skills. So, I'm going to show you 2 ways of doing it. They're pretty much the same. It's just kind of slightly different perspectives. One of them skips a step. So method 1. Our first step for method 1, and for method 2 really, is going to be to figure out what the common denominator is. And so again, if you haven't seen 6.3.2 and you don't know how to find a common denominator for these things, I would definitely make sure you go and do that first. Since we're dealing with numbers, this is pretty approachable. Our common denominator for 2, 3, and 4 is just going to be 12. Once you've got a common denominator, just like when we were adding and subtracting, you're going to rewrite all of your terms, so every single term on both sides of the equation, to get that common denominator. It's really important that you do it to every single term, right? So if you don't, things are not going to go very well for you. So in this case, we have x over 2 plus 3 over 4 equals 2 over 3. And so I want to turn all of those denominators into 12. So I'm going to multiply this first fraction by 6, the second one by 3, and the last one by 4. And that is going to get me 6x over 12 plus 9 over 12 equals 8 over 12. So now that we have a common denominator on everything, what we can now do is to start to solve. But when we're solving, we need to get rid of the denominator to isolate x, right? So what we can do is we're going to multiply every single term by that common denominator. And when we do that, it's actually just going to cancel out all of the denominators. So our 6x over 12 is going to get multiplied by 12, or 12 over 1 if you prefer. The same thing's going to happen to our 9 over 12 and to our 8 over 12. And so when we do that, all of these 12s are all going to cancel out. And what we're going to be left with is the much easier 6x plus 9 equals 8. And notice, so all the denominators are gone. One thing I really do need to emphasize, though, that entire process of multiplying everything to get rid of all of the denominators is only when you're solving. So you're not going to try to do this when you're adding or subtracting, right? If you're adding or subtracting fractions, if I gave you, say, 2 over 3 plus 5 over 3, you wouldn't go and cancel out those 3's and tell me that this equals 7. Because you know that doesn't equal 7, right? 2/3 and 5/3, that's a pretty small thing. What it should equal is 7 over 3. So you're not going to do it for adding. You're only going to do it for solving. Please. It's a really common mistake, and it completely messes things up when you're adding or subtracting. All right, so back to where we were here. 6x plus 9. All that's left to do now is just to solve. So 6x plus 9 equals 8. This is now just a pretty basic linear equation. I'm going to isolate x by subtracting 9 on both sides to get 6x equals negative 1. And then I'm going to divide by 6 to get my final answer of x equals negative 1 over 6. And so that's it. That's your first method. Get a common denominator, get rid of the common denominators, solve. Method 2 is pretty similar. It's just going to kind of combine a couple of those steps together. So we're going to do the same equation, x over 2 plus 3 over 4 equals 2 over 3. Step 1 is still going to be to find the common denominator. And so since it's the same question, it's going to be the same common denominator of 12. But method 2 is going to skip the second step from before. We're not going to get everything over the common denominator. We're actually going to go straight to the multiplying stage. So we're going to multiply everything by the common denominator directly. And so when we do that, our multiplication is going to be a little bit more complicated now, because things aren't just going to cancel out. We're actually going to have to put a little bit of thought into things. So I'm going to multiply everything by 12, just like I did before. And so from this first term, when I do x over 2 times 12 over 1, the 2 and the 12 are going to simplify, but now it's going to be a 1 and a 6. The 4 and the 12 are going to become a 1 and a 3, and the 3 and the 12 are going to become a 1 and a 4. And so now, when I multiply all this out, right, x times 6 is going to get me 6x, 3 times 3 is going to get me 9, and 2 times 4 is going to get me 8. So you end up in the exact same place with slightly fewer steps, but I do find it takes a little bit more brain power and is probably a little more likely to lead to mistakes. So I personally am not likely to do it this way. I'm usually going to find the common denominator, get the common denominator, and just cancel things out. Our last step here is going to be to solve. It's the same solving that we already did, so I'm not going to show it again. We get x equals negative 1 over 6, just like we did when we solved the exact same equation right here. All right, so let's try one that actually has variables in the denominator, because that's the whole point of what we're doing, right? So we want to solve 6 over x plus x over 2 equals 4. Still not overly difficult, right? Not a whole lot going on here, but we do need to start small. So our common denominator here, remember, it's just going to be all of the different factors from all of your different denominators multiplied together. So in this case, our common denominator is just going to be 2x. And so I'm going to get that common denominator. And remember, you do that by just multiplying every denominator by what it's missing. So my first denominator is missing the 2. And my second denominator is missing the x. So I'm going to multiply the first fraction by 2 and the second fraction by x. Where a lot of people are going to go wrong here is they're going to forget that the 4 is also a term in this. And I mentioned, back when I was saying what to do, that you multiply every term on both sides to get that common denominator. So even though this one doesn't look like it has a denominator in it, it does. This is 4 over 1. And so I also have to multiply this one by 2x to make it match. Every term needs that common denominator. So when I do that, I'm going to get 12 over 2x plus x squared over 2x equals 8x over 2x. Now that all of my terms have the common denominator, I can multiply everything by 2x. And all of those 2x's are just going to cancel each other out. And so what we're left with is 12 plus x squared equals 8x. And so what we need to do now is ask ourselves, okay, how do we solve this? This is not a linear equation. This is a quadratic equation. Remember, when you are trying to solve quadratic equations, you have to have all of your terms on one side. The equation has to equal 0. So what we need to do now is move that 8x over to the left. So we're going to subtract 8x on both sides. And I'm going to do a little bit of rearranging. So we're going to end up with x squared minus 8x plus 12 equals 0. Now at this point, we're going to solve it probably in one of two ways, either by factoring, which is something we've done a lot of in this unit, so we're hopefully getting pretty good at, or maybe if it's not factorable, we might have to use the quadratic formula. This one is factorable, so it's going to factor to x minus 6 times x minus 2, which is going to give us our solutions of x equals 2 and x equals 6. Don't forget, this is a rational expression or a rational equation. Anything with rational expressions in it, we do need to do NPVs. So we've also got an NPV at the end here of x cannot be 0, which comes all the way back here from this x that was in the denominator. And so there we go. That would be our answer to this question. Continuing on. So we're going to solve negative 10 over x squared minus 3x minus 4 equals 2 over x plus 1. And so this one doesn't look too bad. It's actually only got 2 terms instead of the 3 we had last time, which is typically going to make things easier. So our first step should probably be to factor that first denominator. So multiplying to negative 4, adding to negative 3, that's going to be x minus 4 and x plus 1. So our common denominator is, well, just x minus 4 times x plus 1. So our first fraction actually doesn't need anything. It's got everything we want, so it's just going to stay exactly as is. Our second fraction is missing the x minus 4, so I'm going to multiply by x minus 4 in the numerator and the denominator. So when I do that, I'm left with negative 10 over x minus 4 times x plus 1 equals, and we're going to have to distribute on the right here, 2x minus 8 over x minus 4 times x plus 1. So now we want to get rid of those denominators, so we're going to multiply both sides of this by x minus 4 times x plus 1. That's going to cancel out the x minus 4 times x plus 1 on both sides, and is going to leave us with the much simpler negative 10 equals 2x minus 8. And now this is what we want to solve. So we're going to go through our solving process. We're going to add 8 on both sides. So we've got negative 2 equals 2x, and we're going to divide by 2. To get us our final answer of x equals -1. Our NPVs are x cannot be 4 or -1. And so at first glance, this seems like we're done, everything's great. But if you actually stop and you look at what we've ended up with here for a second, you'll hopefully see that there's something wrong. And that something is the fact that our solution of x equals -1 is one of our NPVs. So we specifically said that x can't be -1, but that's what we got as our answer. And so that is something that's going to happen. So much like when we were dealing with radical equations and we ended up with some solutions that just didn't work out, we've also gotten a solution here that doesn't work out. And so bringing back some vocab from back then, our solution is an NPV, so it's not a real solution at all. So if you think back to what we learned in chapter 5, we would say that x equals -1 is an extraneous solution. If we had a different solution here that worked, that would be what we would go with. But since this was our only solution and it is extraneous, there are in fact no solutions to this equation. So we don't have to go through the entire process of checking like we did in chapter 5. All we have to do is just compare our solutions to our NPVs to see if there's any crossover. If there is, we have to get rid of them. If there's not, things are fine. All right, one more for you to do on your own. So if you could, please solve 9 over x squared plus 10x plus 21 equals 4 over x squared minus x minus 56. So solve it, get your NPVs, make sure that there's no crossover there, and then see how you do after you're done. So if we factor this, we end up with x plus 3 and x plus 7 on the left, and then x minus 8 and x plus 7 on the right. So our first fraction, well, actually our common denominator, should probably talk about that first. Our common denominator for this is x plus 3 times x plus 7. So it's typically easiest to just start with the entire first denominator. So x plus 3 times x plus 7. And then from that, we also need to have an x minus 8 for the third, or for the second denominator. So to go from here, our first fraction is missing the x minus 8. So we're going to multiply by x minus 8 on the top and the bottom. Our second fraction is missing the x plus 3. So we're going to multiply by that on the top and the bottom. If we distribute this, we end up with 9x minus 72 on the left over that common denominator. And then on the right, we've got 4x plus 12 and the same common denominator. So we can be a little bit lazy here. And instead of showing that we're going to multiply both sides by the common denominator, I'll trust you to just cancel them out. So since we've got the exact same denominator on both sides, at this point we can just cancel out both of those denominators directly. And so we're left with 9x minus 72 equals 4x plus 12. This is not quadratic, it is linear. But we do have x's popping up in multiple places, so we want to move all of those x terms to one side, probably the left, and everything else over to the right. So in this case, we're going to add 72 to move the 72, and we're going to subtract 4x to move the 4x. Once that's done, we're left with 5x equals 84. And to solve that, we're going to divide both sides by 5. So our final answer is x equals 84 over 5, or we might want to give that as a decimal. So as a decimal, that would be 16.8. We do need some NPVs, although typically chances are if your solution is a decimal, it's probably not going to overlap with your NPVs. It's not guaranteed, so you do need to be sure. In this case, our NPVs are x cannot be -3, -7, or +8, not -8 there, sorry. So -3, -7, and 8. And so there's your first step into solving rational equations. Once you've got the hang of this, move along to the 6.4.2 video, where we're just going to do the same thing, but we're just going to see some more difficult examples. So there won't be anything new introduced necessarily. We're just going to make things a little bit more challenging.